Good day to the committee. Today, my group and I are going to review a journal titled as Comparing Normal, Log Normal, and Weibull Distributions for Fitting Diameter Data from Akashmani presentation in the northeastern region of Bangladesh. In this article authored by Kayas and the others, which compare three statistic distributions, normal, log normal, and Weibull for modeling diameter at breast height or DBH. Data of Akashmani plantation in northeastern Bangladesh. The goal was to find the most suitable distribution to represent stand structure across different age groups. DBH is a key indicator in forest inventory and management, as it reflects the growth, regeneration, and overall dynamic of a stand. Since DBH data are often skewed due to ecological and management factors, selecting an appropriate statistical model is essential for accurate analysis and sustainable forest planning.
Akashmani is a fast-growing tree species widely planted in Bangladesh for its ecological adaptability and economical value. However, understanding its stand structure is difficult, especially in plantations that lack consistent management. These forests often show irregular growth and variation in tree size, which leads to non-standard often skewed DBH distributions. Choosing the wrong model can result in poor forest planning and inaccurate growth forecast. The main problem this paper addresses is how to select an appropriate statistical model to represent these DBH patterns across different age groups. In this study, the author used statistical distribution fitting technique to model the diameter at breadth height or DBH of trees. First, the normal distribution is the most classical and widely known. It is symmetrical and bell-shaped, with its peak at the mean value mu and the spread determined by the standard deviation sigma. However, its assumption of symmetry limits its ability in skewed datasets. Next, the log-normal distribution is used when the logarithm of a variable follows a normal distribution. Its density function is skewed to the right, which makes it more suitable for biological measurements, such as tree diameter. It works by transforming the data using a log function, estimating parameters in the log space, and then converting the fit model back to the original scale. The Weibull distribution is a highly flexible model with three parameters: location parameter A, scale parameter B, and the shape parameter C. The PDF curve can be a variable due to the three parameters. This flexibility allows it to fit a wide range of ecological data structure, especially those with heavy tails or concentrate small diameter values. For parameter estimation, two methods were used: maximum likelihood estimation (MLE) and the method of monuments (ME). MLE finds the parameter values that maximize the likelihood of observing the data. It is known for being consistent and efficient, especially with large samples. ME, on the other hand, equates samples moments with theoretical moments to estimate parameters. Finally, the KS test was used to assess the goodness of fit. This non-parametric test compares the empirical distribution of samples with the cumulative distribution function of the theoretical model. If the difference exceeds a criterical value, the model is considered a poor fit. These methods together allowed the researchers to evaluate which distribution most accurately modeled the tree diameter data across different standard age groups.
Hello everyone, today I will talk about a study that compares three statistical models for three diameter data, the normal and the log normal and the variable distribution. The results shows that the log normal and variable distributions are better than the normal distribution. This is because three diameters in the axonal plantation are not balanced. They are skewed to the right, so the normal distribution cannot fit them well. Among these methods, the variable distribution performs best. It has a shape parameter that can change the curve. This helps to describe both small and large trees in different age groups. The study uses two methods to calculate variable parameters: maximum likelihood estimation and movement estimation. Both work well, but maximum likelihood is more stable, especially for young plantations. In short, the variable mode is flexible and useful for modeling tree growth over time. And now let's look at some problems in the paper and how we can improve them. The authors use a KS test to check if the model fits the data, but this test only gives a yes or no result. It doesn't compare which mode is better. Also, it ignores the errors in the estimate parameters. The paper doesn't use helpful tools like AIC or BIC. These can compare modes and show which one fits best with fewer parameters. It also doesn't show standard error or confidence intervals for the estimated values. That makes the result hard to trust. Another issue is that the model only looks at tree age, but factors like slope, soil, and forest location also affect tree size. We suggest using mixed effect models to include those factors and make the model stronger. Finally, I will share how these models can be used in other areas. Variable and log normal distributions are not only for trees, they are also used in wide energy, public health, and traffic safety. In wind power, variable is used to model wind speed. This helps to plan wind farms and predict electricity production. In disease control, log normal is used to model incubation time, like for COVID-19 in traffic. Variable helps to understand how often accidents happen. These models are also used in desert risk and survival analysis. For example, they help to predict how long people survive with a disease or when a sort might happen. In the future, we can combine these models with AI and data to study forests, health, or climate in more powerful ways.
In this study, we reviewed the use of three statistical distributions, normal, log-normal, and the variable, for modeling DBH data in cashew plantations in northeastern Bangladesh. The results show that the normal distribution, due to its assumption of asymmetry, failed to accurately model most age groups. Both the log-normal and the variable distributions perform better, with the variable showing greater flexibilities. Its shape parameter controls skewness, and the location parameter helps describe small diameter dominance. Methodologically, the study used the KS test and the two-parameter estimation methods, MLE and ME. However, the study also noted limitations, including the lack of model selection criteria like AIC and the insufficient control of ecological viability. In conclusion, the Weibull distribution is a robust and a recommended tool for modeling uneven age or unmanaged forest stands.